All right, today we're diving into something really fascinating. It's a strategy for teaching an AI about a tool that it physically can't even use. Now, that sounds totally impossible, I know, but it's actually this brilliant blueprint for a whole new way of doing research, one that combines an AI's raw brain power with a human's ability to interact with the world. So, this really gets to the heart of it, right? I want you to imagine you have to become a world-class chef, but you can't taste food. You can't even go into a kitchen. How would you possibly do it? Well, that's pretty much the exact same challenge facing the AI in our story today. So let's meet our two main characters. On one side, we have Jules, a really powerful AI model. And on the other, we have its subject, a modern, super fast software runtime called Bun. Now, if you're not familiar, just think of Bun as a new kind of engine for running JavaScript code, kind of like a competitor to Node.js. It's complex, it's powerful, and it's all about performance, which makes it the perfect, impossible subject for an AI to try and master from the outside looking in. And this is where things get really wild. See, Jules is a pure reasoning engine. It lives in this digital space where it can't run other programs, it has no access to a file system, it can't just execute code like Bun. So, how in the world can it learn all the tiny details of something it can never, ever actually touch? Now, this slide just nails the whole problem. On the left, you see its incredible strengths. I mean, it can analyze code, design these complex systems, and even think about performance on a theoretical level. But then, look at the right side. Those are its hard limits. It's a brilliant mind trapped in a digital box, completely unable to do the most basic things we developers do every day without even thinking about it. So, you've got this impossible challenge. What's the solution? Well, the answer is this incredibly ingenious framework that was designed for exactly this situation. It's called the Jules Protocol. And here's the thing you have to understand about the Jules Protocol. It isn't just some simple question you fire off to an AI. Nope. It's a formal, strategic plan. It lays out a whole series of phases that guide the AI's research, and this is the crucial part. It sets up a structured partnership with a human who gets to be its hands and eyes in the real world. Okay, so the full protocol actually has 7 phases, but you can really boil down its genius to these 3 core ideas. First, the AI has to build a perfect mental map of the subject. Second, you have to clearly define the jobs for the AI and its human partner. And third, they both enter this powerful feedback loop. The AI generates ideas, the human tests them, and the AI refines its understanding based on what actually happens. So let's dive into that first big stage, because honestly, this is the foundation for everything else. How does an AI that can't even run a program build a complete, functional, deep understanding of it? The protocol's first move is just brilliant. It tells Jules, okay, before you do anything else, you are going to build a structured, hierarchical knowledge map. And this isn't about passively skimming the docs. No, it's about actively constructing a formal model of every single piece of Bun, from its core architecture all the way down to its specific APIs. It's basically building a brain on the topic, piece by logical piece. But, just having a map isn't enough, right? To really get something, you need to be able to play with it. And since Jules can't run Bun for real, the protocol has it do something even more clever. It tells Jules to build a simulation, a kind of virtual playground for Bun, right inside its own mind. And this quote right here is the absolute game changer. This simulation layer is the magic trick. It's a virtual sandbox complete with mock behaviors, API signatures, even potential errors. This is what allows Jules to pretend to run code, to predict what's going to happen, and to reason about its behavior without ever leaving its digital prison. It's the key that unlocks everything. Okay, so now our AI has its digital grain and its virtual playground, but it's still stuck in the box. It needs a connection to the real world, and that's where the second core stage of the protocol comes in, defining that all-important collaborative workflow between Jules and its human operator. And this table just shows it perfectly. It's this beautiful division of labor. Jules does all the heavy mental lifting, generating code, analyzing systems, simulating outcomes. Meanwhile, the human is the hands and feet on the ground, actually running the code, benchmarking the performance, and then pasting the real-world results right back to Jules. It brilliantly takes the AI's biggest limitation and turns it into a collaborative strength. And you gotta know, this isn't just some casual back-and-forth chat. The The protocol establishes a really formal system for this partnership, with clear rules for how to debug, how to test, how to give feedback. And that structure is so important. It's what ensures the whole thing is efficient and can actually handle big, complex projects over the long term. All right, so we've got the knowledge map, the simulation, the human partner. What's the payoff? What do we actually get out of all this? This is where the theory smacks right into reality. And this is what's so cool. The output isn't some dusty academic paper. It's something incredibly practical. The protocol actually directs Jules to generate a complete, ready-to-run project template. We're talking the entire directory structure, all the config files you need, build scripts, a README, and example code for a server or a database. It's a fully functional starter kit, designed by an AI that has never run a single line of it. And it gets even better. The final deliverables are basically a complete knowledge package. Jules produces a deep dive research summary, a list of new and interesting experiments for the human partner to try out, and even detailed practical guides for helping people migrate their existing projects over to Bun. So, when you step back and look at the big picture, what's the real takeaway here? The Jules Protocol is so much more than just a clever prompt. It's a blueprint for a whole new way of doing deep research. It's a cognitive partnership that combines the absolute best of an AI's reasoning with the indispensable value of real-world human execution. Now, this whole thing was designed for software, right? But just think about it for a second. Where else could you use this? Imagine a geologist using this to direct a rover on Mars, or a medical researcher designing drug trial protocols for a lab halfway around the world. The possibilities are just massive. So what impossible problem would you tackle with a method like this?